Hello dear students, good afternoon. Today we are going to discuss another section of general mechanics, that is kinetic energy of the rigid body. We already seen what is angular momentum of a rigid body, right? Now kinetic energy, right? So what we seen, a body under rolling, suppose a rigid body of radius, moment of inertia of the rigid body, say I center of mass, about center of mass axis, the velocity of center of mass v center of mass, and angular velocity of the body, rotating body omega, then kinetic energy, right? Suppose the body, right, both the translational with the center of mass and it is rotating also omega, right? So it has two terms in its kinetic energy, right? That is, one is due to translational kinetic energy, other part is rotational kinetic energy, right? So sum of translational kinetic energy plus rotational kinetic energy, that is the total kinetic energy, that is T is equal to half V center of mass half mv square, right, and half I center of mass omega square, right? So this I center of mass is the moment of inertia of the body about the rotating axis, right? So this expression we already seen, rotational kinetic energy expression separately and translation kinetic energy separately. So during rolling motion, it is the sum of rotation plus translation, then sum of the kinetic energy is the total kinetic energy, right? So it's a very simple concept. Now let us come to one problem based on this. See here, one question given: a sphere of mass m and radius r, having velocity of the center of mass v0, as friction of surface is enough to so that the sphere achieving the condition of rolling without slipping. Rolling without slipping means that is pure rolling motion. That means at time we studied v center of mass is equal to r omega, right? R omega. Now let us see, that is total kinetic energy is sum of translation. So half m into v center of mass velocity is v0, center of mass velocity they taken v0, that is v0, right? Now half into, this is a sphere of radius r, so its moment of inertia half I center of mass, that is 2 by 5 mr square into omega square, right? Now we substitute v0, that is omega r, then what I can write, this omega is equal to v0 by r, that value you substitute here, then half mv0 square plus half into 2 by 5 mr square plus v0 by r the whole square, omega replace 7 by 10 mv square, right? Now let us come to another question, that is, suppose a road, right, a road of length L pivoted at one of its end. If road is constrained to move in the YZ plane, then find the total energy of the system, find the angular frequency of the small oscillation, right? So here it is it is not YZ plane, it is XY plane we can consider, right? Or if ZY plane means here the parameter taken is not correct. Why? Because in ZY plane Z coordinate and Y coordinate only vary, right? But it is different here, all right? So we can consider this as XY plane, right? That is best. XY plane we can select, right? XY plane if we chose means what we can write? We can write, see here this road initially this direction, right? Now it is simply rotating with an angle theta by about this end, right? So the center of mass location you think, Center of mass, this is the center of mass of this rod. That is translating from this point to this point, right? At the same time, this rod is rotating by an angle theta. So we have the total kinetic energy we can represent sum of translational kinetic energy plus sum of rotational kinetic energy. Now regarding this translational kinetic energy, half m into here the point both y and z coordinate changing, then x dot dy by dt is the y coordinate velocity, and suppose this is xy coordinate, then dx by dt is the y side velocity. Dy by dt I can write as y dot, dx by dt, say dx by dt I can write as x dot, right? That sum of kinetic energy means half m into velocity of x direction, that is half mv square vx square, that is x dot square, and velocity of y direction, that is y dot square, right? Dy by dt is vy, this is vx, am I right? All right. Now half I center of mass omega square. Now from the diagram, after getting this equation from the diagram, it is clear that see this point is, this is the center of mass, right? So this length, what rod length is, this is L by 2. So this is x coordinate, this is y coordinate. If this is theta means this is what this is L by 2 sine theta, right? X is equal to L by 2 sine theta, right? Opposite side, and this y direction you can write as L by 2 cos theta. Okay, so we made components. So x I can write as L by 2 sine theta, y I can write L by 2 cos theta. Then what is x dot? L by 2 into sine theta on differentiation cos theta, theta on doing theta dot, and y dot on doing right, this one doing L by 2 into cos theta on doing minus sin theta, theta on doing theta dot. What is theta dot? Theta dot is equal to d theta by dt, that is equal to omega, angular velocity, right? So by substituting all these values, t is equal to half m into x dot square L by 2 cos square L square by 4 into cos square theta, theta dot square, plus y dot square, that is L square by 4 cos square theta. Then by adding x dot square plus y dot square, what x dot square plus y dot square, by substituting this value and this value, so you can take L square by 4 theta dot square out, remaining here cos square theta, here sin square theta, that is equal to cos square theta plus sin square theta is equal to 1. So half into L square by 4 into theta dot square. And a moment of inertia of the rod about its center of mass is what? Ml square by 12. Then half into ml square by 12 theta dot. Then ml square by theta dot square. Right? Similarly, what about potential energy? See, potential energy is initially center of mass here. Right? Initially center of mass here. Then what is the height it rising? That is L by 2 cos theta, center of mass rising height. Suppose a rod here, it is rotating like this. Now center of mass here, initially center of mass here, right? Then this height rising, how we can represent this much height only rising. This is totally, this is what I can write, this is L, and this is L cos theta, right? Now this is L by 2, and then this is, you can write as L by 2 cos theta, this part L by 2 cos theta, am I right? This is theta, so L by 2 cos theta. So after getting L by 2, so what is the height it is rising? This blue colored mark, you think this much height only center of mass. Center of mass initially here, now that this is the level. Then how we find this height rising? Height rising is see total L cos theta, that is L cos theta, right, minus what about this distance? This distance we have to or you can center L by 2 minus L cos theta. You can write as L by 2 minus we can write this as L by 2 cos theta. L by 2 cos theta. Then you can write L by 2 into 1 minus cos theta also, right? So potential energy, right, potential energy is equal to mgh, right? So if it is rising means against gravity only work done, so you can write as minus mgh, all right, minus mgh. Okay, so but here you see any time we taken this coordinate y coordinate we taken as L by 2 cos theta. So height from of the center of mass we take L by 2 cos theta. So what is minus mgh only work against gravity, then mg into L by 2 cos theta. So what is potential energy? Potential energy is minus mg L by 2 minus mg L by 2 cos theta, right? Now total energy, what I can write it, total energy is equal to potential energy plus kinetic energy. Kinetic energy we solved, potential energy also we solved, then total energy is this. Now if energy is conserved means a derivative of this energy will be 0, then again differentiate this, then half ml square by 3, half ml square by 3 into theta dot square on differentiation gives 2 theta dot into theta double dot, that 2 and this 2 cancel, then this part come, right? And cos theta on integration minus sin theta, then minus minus become plus, and again you do theta means theta dot you get, right? So finally by rearranging this equation you can write L by 3 into mass and all we can take out L by 3 theta double dot plus d by 2 sin theta is equal to 0, right? Then sin theta, suppose in a small oscillation theta is very small, so that you can write theta c sin theta is theta, then L by 3 theta double dot plus d by 2 theta is equal to 0. Then by comparing with the original equation, right, what I can write theta double dot plus, right, then 3 by, all right, theta double dot plus 3g by 2l theta equal to 0. That means d square theta by dt square plus omega square theta equal to 0 format. Then what is omega square? 3g by 2l. Omega square is equal to 3g by 2l. Then angular frequency, that is 3g by 2l, right? Now the same thing we studied in lower area. One road is actually one rigid body actually about center of mass, it is rotating. What we studied, that is omega is equal to root I by mgx, right? Then this I is equal to ml square by 12 mg into, right? So it is about the end point only, this is rotating, so moment of inertia you can take ml square by 3. X is equal to L by 2. Why? Because center of mass position from the fixed point, so the road center of mass is located at L by 2. Now m cancel and the square L cancel, then what you can write, this is, right, we can write this is 2l divided by this is actually frequency, omega is, right, 2 pi root I by mgx, all right. So 2l divided by 3g, right? Now this is omega, right? So here we have one 2 pi is there. Now what is our frequency? Frequency is 2 pi by t, then by reciprocal only come, then you come to this expression root 3g by 2l. Right, this is omega value, this is omega value, but frequency is 1 by 2 pi root mgx by I. Right, so you can write a root 3g by 2l. Right, this is this formula for a frequency you can write right 1 by 2 pi root mgx divided by I. Right, or you can write a time period 2 pi root I by mgx. Am I right? All right, now let us go to another question. See here, another question is a rod of mass m and length L suspended from the massless vertical springs with the spring constant K1 and K2 and x1, if x1 x2 be the displacement from the equilibrium position of the two ends of the rod, find the kinetic energy of the system. Right, so first of all we already told this is rotating, this is this two spring system given. Right, so it's a center of mass varying translating. Right, so half mv center of mass at the time this is a spring, it has oscillation, right, with angular frequency omega. So about center of mass oscillation half I omega square. Right, that is oscillatory kinetic energy. Right, now half m into here velocity, suppose x coordinate, here x1 coordinate is there, x2 coordinate is there, both spring, but both are inclined, the extra length inclined by an angle theta. So what is velocity? First spring dx1 by dt, that is x1 dot, and dx2 by dt, that is the second spring velocity, that is x2 dot. Right, so x1, but center of mass position is what, that is x1 by 2, center of mass position is x1 by 2, then x1 1 by 2 x1 dot, then what is net linear velocity? X1 by 2 plus x2 by 2 whole square. Right, now here this is x1 and x2 is considered as a lengthwise distribution. Then about center of mass, what is the moment of inertia? ml square by 12, and right, this theta, right, theta is the angle difference between that. Then what is omega different? Omega, that is theta dot square. We know omega is equal to d theta by dt, that is we can write as theta dot, that is angular velocity square. Right, so angular velocity terms that also we identified, then half ml square by half I omega square, I is ml square by 12. Right, now from this figure sin theta is equal to this difference in, that is x2 minus x1. Right, and so x2 minus x1 divided by L. All right, so a small displacement, a rod of mass length L is suspended from the two massless vertical spring. This is the rod. Right, now what, by oscillation, this rod oscillation difference, this rod rotated by an angle theta, because both having different spring constant, then it is not not elongating in different way, not in the same way, different way it will elongate. Elongation is different for different spring. Based on that, this rod connected between these two spring rotate, that rotating angle difference is theta. Right, so here that also we considered, then x2 minus x1, this is LA, this is x2 minus x1, sin theta is x2 minus x1, or we can small angle theta, we can write sin theta as theta x2 minus x1 by L, then theta dot is equal to differentiating this side, then x2 on differentiation x2 dot minus x1 dot by L. Now we substitute that total energy term, right? Half mv center of mass square plus half ml square by 12 into then a plus b whole square a minus b whole square, and this m by 2 and all we can take. Finally you get an expression like this, right? M by 6 into, right, m by 6 into x1 dot square plus x2 dot square plus x1 dot plus x2 dot, right? So this coordinated, this dot term, x dot means x-axis velocity, y dot means y-axis velocity. So in a two-dimensional space we can represent this component velocity using dot like this, right? All right, now let us come to another question. See here, another question we have. One stick of length L and mass m initially upright on the frictionless table starts falling. The problem to find the speed of center of mass of the function and position. See this also, one stick is like this. Okay, now this is the center of mass position. Now it is falling by, see, because no friction, so it slip like this backward and center of mass position down, right? Now center of mass position initially here, so it is, this part is coming this side and center of mass position getting down like this, and finally it fall like this, right? Then center of mass, then center of mass is along this y direction only keeping, right? Now initially if it is initially it is vertically like this with the center of mass, so total length is L means what is center of mass position from the ground, that is L by 2, right? Now after some time, by falling, center of mass reached here, so what is the new position, center of mass shifted, it is vertical distance y, right? Okay, now this angle is theta, this angle is theta do, this is theta means okay, this angle I given theta. Then what about this distance, total this distance L by 2, here y I taken, that this is L by 2 minus y, all right? Okay, so our aim is, what is our total energy? Total energy is the sum of kinetic energy plus potential energy. Initially total energy is because it is at a equilibrium, so no velocity, so mgl by 2 is the total energy, right? Now after some time, what is the new kinetic energy? New kinetic energy is, that is this only, right? Half, so this rod is rotating by an angle, so rotational kinetic energy half I omega square, omega is theta dot square, and translation, this center of mass shifting from one point to another, then half m y dot square, right? But this y, the corresponding potential energy, what potential energy, this length is changed by from the ground, what is the height, final position L by 2 minus y, then a final kinetic energy U is equal to mg into L by 2 minus y, right? So its height decreasing, so work in the direction of gravity only it is falling, so potential energy is positive, all right? Now total energy, what is it now? Total energy we already seen mgl by 2. Now sum of this energy we can equate to total energy mgl by 2. So we given total energy, sum of these two energy we equate to mgl by 2. Now we have all the term, right? So we can modify this. Now y coordinate, x coordinate and all we can write. See x coordinate, what we can write, see here, this is theta means this also theta, right? Now what about this, this length is L by 2, then this is L by 2 cos theta, this is L by 2 sin theta, by making from this triangle, right? So L by 2 cos theta, x is equal to L by 2 cos theta, and y is equal to L by 2 sin theta, all right? After getting that, y is equal to L by 2 into, so here we write one more time, all right? So L by 2 cos theta, Now we need a y value is what? Y this only. See, this y value we can write as, right, this y value I can write as this y, right, in terms y is equal to L by 2 into 1 minus cos theta. Y is equal to L by 2 into 1 minus cos theta. That means this y is equal to L by 2 minus y, right. Y is equal to L by 2 minus L by 2 minus. See, this from the ground instantaneous position, what is this L by 2 minus y? Y is equal to L by 2 cos theta, right. Then L by 2 minus L by 2 cos theta only the y coordinate of the final center of mass position. L by 2 minus y, that is y is equal to L by 2 cos theta, all right. So y is equal to L by 2 into L by 2 minus L by 2 cos theta, right. So how this come? L by 2, go to the figure, L by 2 into 1 minus cos theta. So y dot you can calculate L by 2, you keep out minus cos theta, 1 on differentiation 0, minus cos theta on doing sin minus sin theta, minus minus cancel, sin theta, theta on doing theta dot. Okay, so theta dot one expression you get created 2 by L sin theta y dot, all right. Similarly, so from this calculation, I center of mass ml square by 12. Now substitute all these in the equation. This y value, y dot value, all substitute. Finally, you can write an equation of motion like this, right? By simplifying this, it is very easy. Here mgl by 2 is there, here mgl by 2, this mgl by 2, this mgl. Then minus mgy will be pending, and here is some squaring every term and rearranging. Here y dot square, y dot square, y dot square you take out, right. Finally, to find y dot you take the remaining term square root, all right. That's why here 1 by 2, right. So basically they may ask given some situation, and maybe they ask expression for y component of velocity. Y dot is y component of velocity, right, dy by dt, all right. This is all about this section, and next section we start with the torque, all right. Thank you.